This is the third type of cable and the most expensive and the most advanced, okay? Fiber optics. Okay, now, sorry, I should come back and I should ask the question first. How do fiber optic cables avoid these problems altogether? Okay, we'll explore that, and then I want you to tell me, well, okay, despite the fact that they're going to be so awesome, why haven't they, replaced UTB or coaxial cable as the most popular kind of cable? So think about those two questions. Number one, how does this, which is it's a piece of glass, okay, and it's very, very thin, by the way. How does it overcome the problems we've been talking about? Yeah. Good. Okay, so the reason why we had all this problem with interference and all that, right, is because, sorry, wrong one. Electricity and magnetism interact with each other. Okay. Now, light does interact with magnetism. Okay, because if you have a strong enough magnetic field, it'll, adjust anything. But it won't produce a magnetic field, and it won't get sort of altered by a magnetic field. It'll just get moved around. Okay. So when you have a look at this, what you can see is light propagating through, this is glass, okay? Now, this is actually a lot thicker than a normal piece of optic fiber. Normal optic fiber is about the thinness of a human hair, okay? So insanely thin. But the reason I picked up this image is because it demonstrates the same concept, okay? So light isn't pinging straight through the optic fiber, okay? Instead, it's bouncing off all the walls, if you like, okay? And when you think about it, that makes sense because optic fiber is not necessarily always in straight lines. Okay, it's actually going to be bouncing a lot if it's curved or something like that. Okay, so that's really sweet. No problems with that electromagnetic interference. So why haven't optic fibers taken over and gone everywhere? Yeah. Okay, number one. So there's more than one reason. Okay, this is optic fiber, and you'll see it spelled both ways, by the way. Like English way and American way. I don't think it really matters. Number one, expense. It turns out that making glass, which is as thin as a human hair, is not that easy. It's a very costly process, okay? And it has to be very precise as well. It can't just be thin. It's got to be exact, okay? What else? What else? What other reasons? Leo? Yes. Good. So it's fragile, right? Okay, because glass, it shatters very easily, right? Now, there are things that can be done to optic fiber to reduce that, but it's still an issue. Yeah. Excellent. This is actually probably the big reason. Optic fiber is great. Electromagnetic interference doesn't really come into the picture. But you know what? Most of us don't really mind having a bit of electromagnetic interference, okay? So all these Ethernet cables that are running around the room, they do the job just fine, even though they're this sort of, this low-tech, sorry, wrong one, this low-tech technology, okay? It still works, it's much cheaper, it does the job. Importantly, it's over a short distance, okay? So what we would have is, you'd use this over short distances, and where the data is not super, super critically important, okay? You would use this over longer distances, and also if you're running past lots of things that are made of metal, okay, because they're going to interfere with your electromagnetics. And then lastly, you use optic fiber when you really need to make sure you can get your data safely, when you're going very, very long distances, okay, and where you have a lot of data to transmit. So if you remember, when we were talking about network infrastructure, okay, we talked about this idea called a backbone. Do you remember that? What's a backbone? We compared it to the spine, right? Hence, backbone, right? And the idea is there are parts of the network that are going to get much more traffic than others. So it's not like a highway, right? Well, most backbones are made of fiber optics, okay? Because they can transmit a lot more data, a lot more reliably, okay?